Hello, and today we're going to continue the chemical bonding units and start talking about the nomenclature of what's called polyatomic ions. So polyatomic ions are ions that consist of more than one atom to form a cohesive charge and behave chemically as a single unit. So it's two or more atoms that have come together and they have formed either covalent or ionic bonds to make an overall charge, or formal charge is what it's called, that's either positive or negative. And so they can be treated as one single unit, as one single ion. So here are a couple examples. Hydroxide, which is oxygen and hydrogen together, and they form an overall -1 charge together. And then carbonate, which is one carbon atom, three oxygens, and they cohesively make a -2 anion. And then ammonium, which almost sounds like ammonia, and I'll get to why that sounds similar here in a second, which is NH4 plus. So it's a nitrogen plus four hydrogens bonded together, but they make an overall formal charge of a +1. So these all are treated as ions, as single unit ions. Nitrate, same thing, a nitrogen with three oxygens that makes a -1 charge. And there's a full list of polyatomic ions that I will be giving you and that you'll be utilizing throughout the year, so just be aware of that. In my class, you're not going to have to memorize the polyatomic ion list. I'll give it to you in class. However, the quicker you can memorize a good majority of them, the quicker you can do problems. So I do encourage you to memorize them in your own time, but I will not make you responsible for memorizing them in my class. I will give you a chart of those on tests and quizzes that you can use and be able to solve problems in chemistry with. So we do apply the crisscross method to polyatomic ions, the same crisscross method as we use for ionic binary compounds. But there is a couple of additional rules. So suppose I'm combining a magnesium ion and a nitrate ion, which is Mg2 plus NO3 minus. Okay, we know that magnesium has one atom, okay, of magnesium, and when we go to nitrate, we have one atom of nitrogen and three atoms of oxygen. The charges don't balance out to zero, so I have to account for the charges by doing the crisscross method. To balance the charges, I have to have two nitrates for every one magnesium. So I'm going to put the 2 there. Now, based off of this, since I put the 2 there, now my atom count changes, and now I have magnesium of one atom, then I have 2 nitrogen atoms and 6 oxygen atoms, and that's because, where my cursor is, there's the imaginary 1 here, so 2 times 1 is 2, that's where I get the 2 from here, and then I had 3 originally in the ion, so now it's 2 times 3, and that's how I get 6. So I need 2 nitrates for every 1 magnesium ion, so the chemical formula has to account for that as well. So what you do is that when you crisscross the charges, when you have polyatomic ions, you always have to add parentheses, because it indicates that you're multiplying the subscript by a particular unit of a particular polyatomic ion. So that's what it's going to look like. So this 2 is going to come down here, and the thing is you can't put the 2 next to the 3 because then it's going to look like you have 32 oxygens, which is not true. So that's why you put the parentheses, because now it's saying it's 2 times whatever is in this. So you still get the 2 of the nitrogen here, so you still have 2 nitrogen atoms, and then 2 times 3 you still get the 6 oxygen atoms, and you still have the 1 magnesium. So again, you can interpret the parentheses as like a multiplication sign between the subscripts. So now I have, again, 1 magnesium atom, 2 nitrogen atoms, and 6 oxygen atoms. So polyatomic suffixes and prefixes. So these do have suffixes and prefixes that you can use and will utilize. So based off the polyatomic chart that I'll give you, you'll see that there are different suffixes and prefixes for each polyatomic ion. What you'll notice is that bicarbonate or binitrate or bisulfate or anything like that, you'll notice that those polyatomics have hydrogens attached to them. So whenever I say bi something, it's actually hydrogen something. So you also hear hydrogen carbonate, hydrogen sulfate, so on and so forth. Other prefixes and suffixes can be demonstrated by a number line, and this is how I think about it. If there's another way you can think about it, or you want to discuss another way to think about it, please come see me. But this is the way I think about it, and it's the most useful to me. So suppose I have a number line. I start off with nitrate, which is what's given to me on the polyatomic chart. This is just on a number line of 0, so this is my general go-to on where to start. Okay. anything that kind of starts off at that 0 line ends in ATE, so it ends in 8. So I have nitrate. All right. Now, if I go up in an oxygen, if I'm adding an oxygen atom to the nitrates, then what it is, I say it's +1. Okay, so it's +1 more atom that was within the first formula. And what it is, it's per the name 8. So it's going to be called per nitrate because I have one more oxygen than the original nitrates. Now, if I go one atom of oxygen down, then I can say that's the -1 version. And what you do is that you replace the 8 with ite, I-T-E. So this becomes nitrite. And then if I take 2 oxygens off and have just NO minus, then I can say that's the -2 spot. And then what you say is hypo, whatever it is, ITE. So this is going to be hyponitrite. Okay. So this is the way I kind of think of it. There are a couple of polyatomic ions that follow this. There are other polyatomic ions that's just how they are. But carbonates, sulfates, nitrates, phosphates, they all follow this kind of trend here. So just be aware of that. So when it comes to naming polyatomic ion compounds, they follow the exact same rules of ionic binary compounds that we talked about last video. So the thing is that since we treat the polyatomics as a single unit, we can use the exact same rules when it comes to naming. So if I take a sodium ion and I add bicarbonate or hydrogen carbonate to it, what I'll do is I'll have the sodium ion plus bicarbonate, and then the same ionic rules from the last video. You drop ion, and then you just add the name of the cation element to the name of the anion, the full name of the anion, which in this case is bicarbonate. So now it's sodium bicarbonate. If I have beryllium and hydroxide, you have beryllium ion plus hydroxide. You drop the ion, and now it becomes beryllium hydroxide. And then lithium, this one's weird because the thing is, if you look at it, if you look at phosphate on your chart, it's PO4 3-. This one is PO3. So this is following that number line rule that I just said. So it's 1- or 1 oxygen less than phosphate. So we know it's going to have a different prefix or suffix to it. So it's going to be the lithium ion plus phosphite. Okay, because it's 1 oxygen less than phosphate. You drop the ion, and now it's lithium phosphite. Okay? All right, so again, kind of a short video. I want to kind of keep these videos in smaller portions because it helps with chunking information. But if you have any further questions in regards to the chart of the polyatomics that I'll give you, or in questions on this video, or bonding in general, please come talk to me, email me, whatever you need to do, so that way you have this stuff down to go on to the next chapters and units and stuff like that. So thanks for joining me on this video. I hope to see you in the next one, and see you in class. Bye.